These are the notes you're going to be taking for lesson 2, day 6, or day 2.6. Okay, unit 2, day 6. We're going to be talking about substitution. We kind of talked about this in the last video, but we're going to hit it again and see how this applies to solving systems of equations. But first, we're going to identify something called the substitution property, which is this. The substitution property of equality states if some value A equals some value B, then B can be substituted for A in any equation. What that means is that B can replace A in any equation. We can take the A value out and replace it with B. What that also means is that if we have a variable equal to a longer expression, that longer expression can replace that variable in an equation. So we're going to look at an example kind of like that. So it might look something like this. If I've got an equation, y equals 2x plus 4, and I've got another equation, y equals 5x plus 7, then I can replace this value of y with the expression 5x plus 7. Since they're both equal to y, I can say these two expressions equal each other. So instead of y equals 2x plus 4, I can write 5x plus 7 equals 2x plus 4. All I did was took this y out and put what y equals from the other equation in its place. Okay, that's an example of using substitution. Well, once we do that in a system of equations, now I have an equation that only has one variable in it. We can solve that equation for that variable. So we're going to actually do an example of a system of equations that uses substitution. All right, so I'm going to write your system like this. First equation is y equals 4x minus 3. And your other equation is 4x plus y equals 5. So we've got a system of two different equations, both using the same x and y values. Rather than trying to graph these to solve them like we did in the last lesson, we're going to use substitution. And so we're going to replace this value of y with this expression that also equals y. We're just going to switch those out. So my new equation looks like this. I'm going to rewrite this bottom equation as 4x plus, but instead of plus the letter y, I'm going to replace it with this 4x minus 3. And then finish writing this bottom equation equals 5. And now I just solve this equation for x. I combine like terms. 4x plus 4x is 8x. I still have a minus 3, and that equals 5. Then we add 3 to both sides to solve for x. So 8x equals 8. And divide by 8 on both sides. So we get that x equals 1. But we're not done with our problem until I also find a value for y. So I'm going to go back to one or the other of the original equations and plug 1 in for x, again substituting, using substitution again, so I can find a value of y. I'm going to choose the first equation because simply it's already set equal to y. So I'm going to rewrite the first equation, y equals 4x, but instead of the x, I'm going to replace it with a 1. And I have to show that that is times 1, not plus 1, not minus 1, it's times. And then minus 3. 4 times 1 is 4. 4 minus 3 is also 1. So in this case, y also equals 1. So we write our final answer as an ordered pair. The x-coordinate is 1, the y-coordinate is 1. If I were to graph these two lines on a graph, they would cross at the point 1, 1. That's what this solution tells me. Okay. All right, we're going to do another example. If you need to turn the page, go ahead. Otherwise, keep writing on whatever side of the paper you're on. For example 2, we're going to start off with this system, y equals x minus 1. is our first equation, and the next equation is 5x plus 8y equals negative 21. And since our first equation has a y by itself, that means I can replace the other y in the other equation with this expression. So when I rewrite that equation, it becomes 5x plus 8 parentheses x minus 1, because I'm replacing just the y with that expression, and I have to multiply all of that expression by 8, so I have to use parentheses. That equals negative 21. Okay, I want you to recognize the first thing to do is to distribute. Excuse me. We're going to distribute first, leaving my equation as 5x plus 8x minus 8 equals negative 21. Then I can combine these like terms. 5x plus 8x is 13x. And then still have minus 8 equals negative 21. Add 8 to both sides. We get 13x equals, negative 13. Then divide by 13 on both sides. Negative 13 divided by positive 13 is negative 1. So our x value is negative 1. We have to take that x value and plug it into one of these two equations and solve for y. I'm going to choose the first one because it's easier to work with. So y equals negative 1 for the x minus 1. Well, negative 1 minus 1 is negative 2. So that's my y value. So my answer is the ordered pair negative 1, negative 2. That's the point where these two lines would cross. And these two numbers would work as x and y in both equations. If I plug in negative 1 for x here, minus 1, that is negative 2y. If I plugged it in here, 5 times negative 1 would be negative 5. 8 times negative 2 would be negative 16. Negative 5 plus negative 16 does equal negative 21. Okay, we're going to do one more example. Here are your two equations. Okay, if you need to pause to copy this down, go ahead. I'm going to keep moving forward though. So in order to solve by substitution here, I have to get one variable all by itself, and the easiest variable to get by itself is the y value. So the first thing we're going to do here is move the x. We practiced doing this in the last lesson. I want it in slope-intercept form, just like last lesson. So I'm going to subtract 2x from both sides of this top equation, changing my top equation now to negative y equals negative 2x minus 17. But this is still a negative y. Well, if that's all I have to change, I can just change it into positive y. But if I change this negative to a positive, these other two negatives change to a positive as well. Whatever I do to one side of the equation, I have to do to the other. So that's a 2x there plus 17. This is the value I'm going to substitute for this y value. Okay? So when I substitute, my equation looks like this. 3x plus 5 parentheses 2x plus 17. Okay? Because we're replacing the y value with this equal expression. That equals 7. Now once again we can distribute first. 5 times 2x is 10x. 5 times 17, when we distribute there, we get 85. And we still have our 3x in front. Okay, so that's 3x plus all of this. And that still equals 7. Now we want to combine our like terms. 3x plus 10x is 13x. And we still have our plus 85, and that still equals 7. We want to subtract 85 from both sides. So we get 13x equals negative 78. Divide by 13 on both sides. And x equals negative 6. Negative 78 divided by 13 is negative 6. That's part of our answer, but we always want to go back and find the other part of our answer using this value. But when we substitute to find the other value, in this case y, we want to go back to an original equation. So I'm going to use the top equation still, but I'm going to the original, not the redone equation here. So I'm going to say 2 parentheses negative 6 instead of x minus y equals negative 17. 2 times negative 6 is negative 12. We're going to add 12 to both sides. So negative y equals negative 17 plus 12 is negative 5. So if negative y equals negative 5, positive y equals positive 5. So our final answer as an ordered pair is negative 6, comma, positive 5. All right, now thank you for following along and copying these down. I wanted to throw something in here at the end of this video just to make sure everybody's paying attention and listening, as well as writing things down. If you have these notes completed when you walk into class next time, there will be a reward for that. You will have less homework to do if you have these notes completed when you walk into class. So let's see if you're paying attention.